Chapter 18 Construction Issues Introduction. Objectives. In this chapter, we will discuss issues surrounding building construction, including site preparation and major mechanical systems. At the end of this chapter, you will be able to 1. Identify and describe land use and site requirements necessary for construction pertaining to building permits, codes, wells, waste, energy, and site use. 2. Describe the principal aspects and components of a building structure including the foundation, framing, flooring, roofing, and walls. 3. Describe further elements of building construction including insulation, mechanical systems, heating, and AC systems. 4. Describe further elements of building construction including plumbing systems, electrical systems, and safety systems. Key terms. There are a number of important terms in this chapter. Remember to pay particular attention to these terms when you see them. Amperage. Lally columns. Basement. Percolation rate. Beam. Pitch. Burring walls. Plasterboard wallboard. Blueprint. Platform construction. Btu British thermal unit. Post and beam construction. Building envelope. Rafter. Circuit breaker. R value. Crawl space. Septic system. Eave. Sheathing. Fascia. Siding. Flashing. Sill plates. Footing. Slab-on-grade construction. Foundation walls. Soffit. Fuse. Specifications. Girder. Studs. Headers. Voltage. Joists. The New York Bureau of Educational Standards requires that you spend 100 minutes studying the material in this chapter. Your course timer can be found in the upper right-hand corner of your screen. Introduction. As you know, it is important for real estate licensees to be knowledgeable about their products. In addition to knowing about a property and its neighborhood location, it's essential that a licensee take note of the specifics of any property that he or she lists. When a licensee is taking a listing, he or she takes measurements of the property and notes things like style of the home and amount of acreage as a matter of course. But it's also important for the licensee to take note of the condition of the house, including such things as the roof, cracks or chips in the exterior finish, the condition of any masonry, chimney, foundation, patio, any broken windows or doors, type of heating and cooling systems, septic tank or sewer, type of water supply, well, cistern, municipal or private. Noting the home condition does not give the agent license to make judgments about the soundness of the structures. If customers ask for opinions, the licensee should refer them to a professional for answers. But as we said, it is important to be knowledgeable about homes and how they are constructed. With that in mind, this chapter will deal with several aspects of building construction. Land use. There are several issues that a construction project must consider. Some of these issues concern land use, plans and specifications. As you know, residential homes come in a variety of sizes and styles. Before a contractor can begin construction, he or she must file the plans and specifications for the home with the building department as discussed in the previous chapter. The plan for the building is called a blueprint, which is a detailed set of plans that will be used as a guide to construct the building. The blueprint is normally drawn up by an architect or engineer, and it shows the dimensions of each room and how they are laid out. The blueprint also shows the locations of the doors, windows, appliances, and fixtures. It has drawings that show the exterior measurements and the elevations. Blueprints in the real estate industry are commonly referred to simply as house plans. The contractor will use a set of building specifications, along with the blueprint. The building specifications are not drawings, but are written documents that explain the plan. The building specifications typically include the following: a list of the materials and finishes that will be used in the construction, an explanation of the major mechanical systems, heating, air conditioning, plumbing and electrical, an explanation of any features that are not clearly visible in the drawings, a description of how the landscaping will be treated, including a list of those items that will remain on the property. Since the building specifications cover more than just the physical dimensions of the building, other professionals may have input into the design. Land use. As you remember from the previous chapter, there are several other requirements developers face before, during and after construction. Building permits. Contractors and developers must apply for and receive building permits before they can start construction. The blueprints and building specification documents we talked about on the previous screen must be filed with the building department, along with several other documents which could include a survey of the property, a copy of the deed as proof of ownership, approved applications for the proposed work from the plumber and electrician. Once received, the permit should be displayed in a conspicuous place at the site. Codes. During the construction process, the developers must be certain that everything they are doing meets the local building codes. Inspectors will do periodic inspections of the progress to check for code insufficiencies. If any violations are discovered, they must be corrected. Certificate of occupancy. When construction is complete, final inspections will be done, and if all is up to code, the building department will issue a certificate of occupancy. Site requirements. Wells. Most non-rural areas in New York are supplied by a public water system. This system brings water into homes via a pipe system from a municipal water main or a community well. The water is delivered under pressure and usually has, or should have, cut-off valves at each building and at individual fixtures, so that if a problem arises, it can be repaired without having to turn off the entire system. New York on-site well requirements. Many of the residents in upstate New York do not have access to public water. These residents must depend on private wells for their water supply. The New York State Department of Health provides guidelines for the construction of such wells. The guidelines include information about the proper location for the well. Here are a few of the guidelines. The well should be located in an area that will allow adequate access to the well for inspection, maintenance, repair, renovation, treatment, and testing. The well should be in an area that is not subject to seasonal flooding or surface water contamination, or it should be constructed in such a way that seasonal floodwater cannot enter the well. The well should be located up gradient of any potential or known source of contamination unless property boundaries, site topography, location of structures and accessibility require a different location. The minimum horizontal separation distances from potential sources of contamination are published in a table available from the Department of Health. The ground surface immediately surrounding the well casing should be graded in such a way as to divert surface water away from the well. Concrete should not be used for grading purposes. Site requirements. Sanitary waste on site. Sanitary waste systems. In spite of the trend toward public sewerage systems, individual household sewage treatment systems still make up the only method of sewage treatment available to many New York State residents. Having adequate household sewage treatment system standards provide for a safe, sanitary means of treating household wastewater. Properly designed, constructed, and maintained sewage treatment systems minimize the possibility of disease transmission and potential for contamination of ground and surface waters. To deal with this issue, the New York State Department of Health regulates the installation of individual wastewater treatment systems that receive domestic-type sewage flows of less than 1,000 gallons per day. For sewage flows of more than 1,000 gallons per day, the standards set out by the New York State Department of Environmental Conservation also apply. The NISDO publishes a very extensive design handbook that outlines all of the requirements and recommendations relating to on-site sanitary waste systems. Certain designs may require additional information or assistance from local health department staff. Specialized or critical cases may occur when soil is unsuitable, high groundwater, rock, or clay are too close to the ground surface, or concern exists over possible wellspring contamination. In such cases, developers may need professional consultation and the approval of special designs. Site requirements: sanitary waste septic systems. A septic system is an on-site system designed to treat and dispose of domestic sewage. It is used when a sewer line is not available to carry waste to a sewage treatment plant. The individual parts of the system are the septic tank, a distribution box, and a leach field. Bacterial action takes place in the septic tank, where the end products are mainly water, gases, and undigested material, called sludge, that sinks to the bottom of the tank and scum that floats to the top of the tank. The septic tank contains baffles that prevent any scum that floats to the surface and sludge that settles to the bottom from passing out of the tank. The gases that are generated vent to the atmosphere via the plumbing vent system. From the septic tank, the segregated and relatively clear liquid flows into a small distribution box where it is then distributed to several perforated pipes. These perforated pipes then deliver the liquid to a large soil surface area, called a leach field, or absorption field, for absorption. The soil also acts as a filter to remove any small amounts of solids that may be carried along with the liquid. The sludge in the bottom of the tank must be periodically pumped out and properly disposed of. Site requirements: sanitary waste. The NISDO includes a number of guidelines for on-site individual wastewater treatment systems. Here are a few of those guidelines. Areas lower than the 10-year flood level and or areas with slopes greater than 15% are unacceptable for on-site systems. There must be at least 4 feet of usable soil available above rock, unsuitable soil, and high seasonal groundwater for the installation of a conventional absorption field system. Soils with rapid percolation rates should be modified by blending with a less permeable soil to reduce the infiltration rate. Subsurface treatment systems and components of the sewage system must be separated from buildings, property lines, utilities, and wells. To maintain system performance, permit repairs and reduce undesirable effects of underground sewage flow and dispersion. NISDO publishes a table which shows the acceptable minimum separation distances from the various components of treatment systems. Once the required infiltration area is determined by daily flow, percolation tests and soil evaluation, the required usable area of the property for subsurface treatment can be determined. When possible, the developer should set aside an additional usable area of 50% of the system's size for future expansion or replacement. Site requirements: Energy Code. New York State Energy Code. The New York State Energy Code addresses the design of energy-efficient building envelopes and the installation of energy-efficient mechanical, lighting and power systems through requirements which emphasize performance. A building envelope is the separation between the interior and the exterior environments of a building. It serves as the outer shell to protect the indoor environment as well as to facilitate its climate control. New York's Comprehensive Energy Code establishes minimum regulations for energy-efficient buildings using prescriptive and performance-related provisions. It makes possible the use of new materials and innovative techniques that conserve energy. The current Energy Code with changes which became effective October 2016 are available at this website. The Energy Code requires that all new commercial and residential buildings, manufactured housing not required to comply with the U.S. Department of Housing and Urban Development requirements, and buildings undergoing substantial rehabilitation must follow the code. Historic buildings and buildings that do not use either electricity or fossil fuel for comfort conditioning are exempt. Requirements for commercial and residential buildings vary based on the location of the buildings within the state and the type of fuel used to heat the buildings. For example, residential buildings that are heated with electric are required to have higher insulation values. Site use. There are several important factors regarding site use that developers must consider prior to and during construction. Drainage. Drainage is one of the first and more important considerations when preparing a building site. Water entering buildings is one of the major sources of construction claims, so drainage of surface water away from the structure is a critical factor during construction. If possible, the area around the building should be graded so that the land slopes away from the building. When this is not possible, an alternate drainage system should be put in place, such as surface drains or underground perforated drains. In addition, concrete patios, decks, and landings must be installed in such a way as to slope away from the building, so that water will not drain into doorways. Landscaping. Landscaping is a major factor in deterring erosion of the soil at a construction site. During construction, soil will often be without grass, trees, shrubs, and other plants. Without this protective vegetation, storms can move the soil, clog storm drains and streams, and carry pesticides and nutrients into the water. To prevent erosion during construction, the developer can cover bare areas with mulch and other protective cover. On steeper slopes, the mulch can be covered with burlap netting for extra protection. Vegetated and mulched areas increase water filtration into the soil, reducing erosive runoff water. After construction, the homeowner can continue these practices until more permanent landscaping features are installed and take hold. Site use. Appetenances. As you may remember from our previous discussion, an appetenance is anything attached to a piece of land or building such that it becomes a part of that property and is passed on to a new owner when the property sells. It may be something tangible like a septic system or water tank, or something abstract such as an easement or right-of-way. In construction of a subdivision, a developer may acquire ownership of a lot or several lots which may already have appetenances, such as a septic system or utility easements. Shading. The shade, natural or planned in the design, that a structure gets will impact the energy efficiency of the building. If there are mature trees on the property, they can be used to provide natural shade. The placement of the building on the lot relative to the natural, existing vegetation will determine how much sunlight the building will receive at specific times of the day. Walks. Many building departments require contractors to install walkways of some type, depending on the construction site. Most codes require a walkway from the front door to the street or driveway of a residential dwelling. Hvac requires that walkways be installed to all homes and buildings in a subdivision. Some planning boards may require the contractor to build walkways around the subdivision for use by the public. Most walks are built using concrete, tile or brick. Zoning. As we discussed in detail in the previous chapter, zoning regulates the use and development of a parcel of property. The structure. In this section of the chapter, we will discuss and define the typical parts of a structure. Footings. When preparing the site for a structure, the ground itself forms the bed for the structure's foundation. That part of the foundation which transmits loads directly to the soil is called the footing. The purpose of the footing is to spread the load over a greater area to prevent or reduce settling. The footing holds the entire weight of the building. Foundation walls. The foundation wall sits on top of the footing and is usually about 8 inches wide and made of poured concrete or concrete blocks. If the area between the foundation walls has been excavated deeply enough to provide headroom, then a basement has been created. If the foundation area is only partially excavated, then what results is called a crawl space. The National Building Code requires that the foundation wall of a basement or crawl space and floors that come in contact with soil be treated for ground and surface water seepage by the placement of a vapor barrier. A vapor barrier is most often a plastic sheet that keeps moisture from passing through a wall. The New York Uniform Fire Prevention and Building Code follows the National Code in making this requirement applicable in New York. In addition, the New York Code may require that the vapor barrier and/or the area beneath be treated for termites. This requirement is dependent on local conditions. The structure. Slab-on-grade construction. When the ground at a building site is level, the developer can use slab-on-grade construction. The slab is probably the easiest foundation to build. It is a flat concrete pad poured directly on the ground. It takes very little site preparation, Very little formwork for the concrete and very little labor to create. It works well in warmer climates, but it has problems in the north because the ground freezes in the winter. At worst, this freezing can shift the slab, and it can result in cold floors in the winter. Around the edge of the slab, the concrete forms a beam called a stem wall that is perhaps 2 feet deep. The rest of the slab is 4 or 6 inches thick. A 4 or 6 inch layer of gravel lies beneath the slab. A 4/1000 of an inch sheet of plastic lies between the concrete and the gravel to keep moisture out. Embedded in the concrete is 6 inch by 6 inch wire mesh and steel reinforcing bars. This kind of foundation is often referred to as a floating slab. It floats on the soil, with the deeper concrete around the edge holding it in place. In northern climates, the concrete around the edge stem wall has to extend deep enough to remain below the frost line in winter. The structure. Wood framing. Wood framing refers to the framework of the structure. The exterior framing must be large enough and strong enough to support floor and roof loads. The walls must also resist lateral wind loads and, in some locations, earthquake forces. The vertical pieces of wood that are used in this framing are called studs. Studs and exterior walls of 1- and 2-story buildings are at least 2x4 inches with the 4-inch dimension forming the basic wall thickness. Stud spacing is normally 16 inches in exterior walls, although 24-inch spacing of 2x4 studs is acceptable in 1-story buildings if wall sheathing or siding is of adequate thickness to bridge across studs. In 3-story buildings, studs in the bottom story are at least nominal 3x4 to 2x6 inches and may not exceed 16-inch spacing. Studs are arranged in multiples at corners and partition intersections to provide for rigid attachment of sheathing, siding and interior wall finish materials. These same size studs when used horizontally to frame floors and ceilings are called joists. Studs used to frame the roofing system are called rafters. The structure. Floor framing. Floor framing consists of a system of sills, girders, joists or floor trusses and subflooring that provides support for floor loads and gives lateral support to exterior walls. A sill plate is a wooden support member that is laid on top of and bolted to the foundation wall. This sill plate serves as the base for the wall framing. The sill plates are the first part of the frame to be set in place. The floors of the building are supported by a series of joists. The distance between an opposing pair of outside walls is usually too great to be spanned by just one joist. So, when 2 or more joists are required to cover the span, support is provided for the joist ends by girders or support beams. These beams or girders can be made of steel or can be several wooden members fastened together. Sometimes the main floor beam of the structure is supported by lally columns. These are steel cylinders filled with concrete. The lally columns are placed in the crawl space or basement and adjusted to the correct height. Their spacing is determined by the size and material of the main floor beam. The structure. Roof framing. Roof construction must be strong enough to withstand anticipated snow and wind loads. Framing members must be securely fastened to each other, to sheathing and to exterior walls to enable the roof system to serve as a structural unit. A roof rafter is a structural member which supports the roof of the building. Carpenters build rafters to frame the pitch or slope of the roof. The roof ridge beam is the highest part of the frame and forms the top line of the roof. The rafters are attached to the ridge beam at the peak of the roof. The roof sheathing is made up of wood structural panels or 1-inch board lumber which provides a solid base for roof coverings. Structural panels are manufactured in various thicknesses and are usually 4x8 in surface dimension. Recommended spans, spacing between panel edges and the board thickness are stamped on the panel face. Structural panels are installed with the long dimension perpendicular to rafters and with the panel continuous over 2 or more spans. Tying it all together. Wall framing refers to both the exterior and interior walls. We talked a little about the exterior framing on a previous screen. As we said, the wall studs are usually 2x4 in size with 16-inch spacing. Two X6 studs provide more strength and provide a larger opening to pack in more insulation. Those walls that support the ceiling and the roof are called bearing walls. Non-bearing walls are part of the interior framework and do not support the building itself. The studs are arranged in a row with their bottom ends bearing on a long wooden member called a bottom plate or sill plate and their tops capped with another plate called a top plate. Double top plates are used in load-bearing walls and partitions. The double top plate is sometimes called a flitch beam and is made up of two or more structural timbers bolted together with a steel plate sandwiched between them for added strength. Headers are required at window and door openings to carry vertical loads across the opening. Headers may be supported by doubled studs or, where the span does not exceed 3 feet, framing anchors may be used with single supporting studs. Headers are also known as lintels. They support the ceiling and the roof over the doors and windows. Tying it all together. Roof finishing. When roof rafters are installed, they typically extend beyond the structure walls to form an overhang. The overhangs are called eaves. The eaves are the lowest part of the roof. The contractor then installs a thin impermeable material called flashing to prevent water penetration and/or provide water drainage between the roof and the walls. Flashing is often installed over exterior door openings and windows as well. The term fascia is used to describe the vertical fascia board which caps the end of rafters outside the building. The fascia can be used to hold the rain gutter. The finished surface below the fascia and rafters is called the soffit. Wall finishing. The high resistance of wood frame construction to hurricane, earthquake and other natural forces is provided when wood sheathing is nailed to the outside edges of exterior wall studs, plates and headers. Wall sheathing includes plywood, particle board and other structural panels such as wafer board, oriented strand board, structural insulation board and 1-inch board lumber. This sheathing must be applied in strict accordance with manufacturer's nailing requirements to provide a rigid, yet resilient, wood frame system. Some structural panels function as both sheathing and siding. Siding can also be metal or vinyl. For interior wall finishing, contractors use plasterboard, wallboard or sheetrock. Types of frame construction. There are 3 types of frame construction used by builders. The type of frame construction we have been discussing is known as platform construction. In platform frame construction, first floor joists are completely covered with subflooring to form a platform upon which exterior walls and interior partitions are erected. This is the type of construction most generally used in home building. Another type of frame construction is called balloon construction. In balloon frame construction, exterior wall studs continue through the first and second stories. First floor joists and exterior wall studs both bear on the anchored sill. This type of construction is not widely used today. The third type of frame construction is called post and beam construction. In this framing method, wider beams are spaced up to 8 feet apart. Floors and roofs are covered with 2-inch planks. These serve as subflooring and roof sheathing, and, where tongue and grooved planking is used, provide an attractive finished floor and ceiling. The ends of the floor and roof beams are supported on posts which provide the wall framing. Supplementary framing between posts permits attachment of wall sheathing and exterior sidings. Energy efficiency. R factor. All the materials that are used in construction absorb and transfer heat. 80 to 95% of this heat is transferred from the warmer side to the cooler side by conduction, convection or radiation. The R factor is the degree or resistance to the heat transfer. The R factor of a surface determines how quickly heat is conducted across it. The larger the R factor, the greater the insulation value. Exterior walls will usually use insulation with an R factor of 13. Floors and crawl spaces are 19, attics are 30 or higher. The New York Energy Code requires minimum R values for insulation. Types of insulation. There are several categories of insulation: loose fill, batts and blankets, rigid board, spray foam and reflective. Loose fill. Loose fill insulation includes loose fibers or fiber pellets that are poured or blown into building cavities or attics using special equipment. It generally costs more than batt insulation. However, it usually fills nooks and crannies easier, reduces air leakage better, and provides better sound insulation than batt-type insulation. Cellulose fiber, made from recycled newspapers, is chemically treated for fire and moisture resistance. It can be installed in walls, floors or attics using a dry pack process or a moist spray technique. Fiberglass and rock wool loose fill insulation provide full coverage with a system that involves blowing insulation into open stud cavities behind a net. Loose fill insulation typically has a value of approximately R3 to R4 per inch. Cellulose fiber has approximately 30% more insulating value than loose fill rock wool for the same number of inches installed. Energy efficiency. Batt and blanket insulation is made of mineral fiber, either processed fiberglass or rock wool, and is used to insulate below floors, above ceilings, and within walls. Generally, batt insulation is the least expensive wall insulation material but requires careful installation for effective performance. This type of insulation is best suited to a standard joist, rafter, or stud spacing of 16 or 24 inches. Batts and blankets come in widths to fit securely between the wood framing members. Some come with a radiant barrier backing. Batts generally come in lengths of 4 or 8 feet. Blankets come in long rolls that are cut to the desired length for installation. Both batts and blankets typically have an R value of approximately R3 per inch of thickness. Rigid board. Rigid board insulation is commonly made from fiberglass, polystyrene, or polyurethane and comes in a variety of thicknesses with a high insulating value of approximately R4 to R8 per inch. This type of insulation is used for work on flat roofs, on basement walls and as perimeter insulation at concrete slab edges, and in cathedral ceilings. For interior applications it must be covered with 1 2-inch gypsum board or other building code approved material for fire safety. For exterior applications it must be covered with weatherproof facing. Energy efficiency. Spray foam. Spray foam insulation is a 2-part liquid containing a polymer and a foaming agent. The liquid is sprayed through a nozzle into wall, ceiling, and floor cavities. As it is applied it expands into a solid cellular plastic with millions of tiny air-filled cells that fill every nook and cranny. Spray foam insulation should be applied by a professional using special equipment to meter, mix, and spray into place. Spray foam insulation is commonly used for retrofits. It is good for irregularly shaped areas and around obstructions. Spray foam materials cost more than traditional batt insulation. However, since spray foam provides both insulation and an air barrier, it can be cost competitive with batt insulation because it eliminates the steps for airtightness detailing, such as caulking, applying house wrap and vapor barrier, and taping joints. Reflective. Reflective insulation, also called a radiant barrier, is a metallic foil material designed to block radiant heat transfer across open spaces. Reflective insulation is most effective at reducing cooling bills in hot, sunny climates. The effective R value of the product will vary depending on the direction of heat flow. The foil surfaces face airspaces, reducing the radiation across the airspace. Check your understanding. Print this screen, answer the questions and then advance to the next screen to see the answers. 1. What site requirements are regulated by New York State? 2. What does a footing do? 3. What is a sill plate and what does it do? 4. What are the 3 types of frame construction? Check your understanding. Answers 1. What site requirements are regulated by New York State? New York regulates wells and sanitary waste systems. 2. What does a footing do? Supports the entire weight of a structure. 3. What is a sill plate and what does it do? A sill plate is a wooden support member that is laid on top of and bolted to the foundation wall. This sill plate serves as the base for the wall framing. 4. What are the three types of frame construction? Platform, balloon, post, and beam. Major mechanical systems. Now that we have discussed the structure itself, let's move on to talk about the inner workings of the structure, those major systems that must be installed to make the building livable, namely the heating, air conditioning, plumbing and electrical systems. Ventilation. Ventilation is the intentional movement of air from outside the building to the inside. Ventilation air is that air used for providing acceptable indoor air quality. When people or animals are present in buildings, ventilation air is necessary to dilute odors and limit the concentration of carbon dioxide and airborne pollutants. Ventilation air is often delivered to spaces by mechanical systems which may also heat, cool, humidify and dehumidify the space. Many heating and cooling systems are referred to as HVAC systems. The acronym HVAC means heating, ventilation, and air conditioning. Ventilation systems have exhaust fans and ducts to remove stale air from the building, while introducing fresh air to replace what has been exhausted. Heating systems. Residential heating systems typically fall into one of these categories: hot water, steam, forced air or electric. Hot water system. Hydronics is the name for the use of water as the heat transfer medium in heating and cooling systems. Some of the oldest and most common examples are steam and hot water radiators. In any hot water system, the water is heated in a boiler and circulated by means of one or more circulator pumps. A system may be broken up into individual heating zones using either multiple circulator pumps or a single pump and electrically operated zone valves. Heating systems. Steam system. A steam system delivers steam to radiators or other heating elements where the steam gives up its heat and is condensed back to water. The radiators and steam supply pipes are pitched so that gravity eventually takes this condensed water back down through the steam supply piping to the boiler where it can once again be turned into steam and returned to the radiators. Forced air. A forced air heating system draws room air through ductwork and a filter into a furnace, where the air is heated. The warmed air is then blown back to rooms through ductwork. A forced air system consists of an air filter, blower, heat exchanger element coil, and various controls. Like any other kind of central heating system, thermostats are used to control forced air heating systems. Forced air heating is probably the type most commonly installed in North America. Electric heat. Electric heating in homes is usually in the form of baseboard heaters along the walls of a room, although it can be in the form of a heat pump. Electric heating has several advantages. It can be precisely controlled to allow a consistency of temperature within very narrow limits. It is cleaner than other methods of heating because it does not involve any combustion. It is considered safe because it is protected from overloading by automatic breakers. It is quick to use and to adjust. And it is relatively quiet. Application of heating systems. Most heating systems use a furnace to heat the air and a ductwork system to disperse the heat. There are three types of air furnaces. Electric. An electric furnace uses a resistance heating element to create heat directly in the airstream. Inside the jacket or cabinet will be controls, a blower, and the circuit breakers for the heating elements. Some furnaces have the breakers accessible from the outside of the cabinet. Oil-fired. Oil-fired furnaces have a heat exchanger, which is the place where the fuel is burned. Oil-fired systems require a storage tank, either above or below ground, to hold the fuel that is delivered to the homeowner. Oil-fired furnaces and boilers are a popular choice in areas of the country with limited access to natural gas, such as the Northeast. Gas-fired. Gas-fired furnaces have a heat exchanger to burn the fuel, which in this case is either natural gas or a petroleum gas such as propane or butane. This type of heating is popular in New York because it is less expensive and eliminates the need for oil delivery. Oil storage tanks. The Department of Environmental Conservation does not regulate underground storage tanks or above-ground storage tanks that are less than 100 gallons. This would include most residential heating oil tanks. However, Homeowners are not exempt from reporting leaks and spills and arranging for cleanup and/or repair when they occur. Most tanks have a life expectancy of 10 to 15 years without problems. If problems occur with a tank older than 15 years, the tank should be removed or properly closed down. Air conditioning. Now that contractors install HVAC systems in most new homes, central air conditioning has become much more common. Most air conditioning units are situated outside of the home or building, either near a wall or on the roof. However, in some instances the unit could be located in the basement of the structure. Major components. The air conditioning unit pumps liquid refrigerant into the air handling unit, the unit inside the home that generates heated or cooled air. The most common refrigerant used in air conditioners is Freon. The IU generates cool air and forces it through the home through the ductwork and into rooms. The ductwork system also returns air from the rooms back into the IU for recirculation. Meanwhile, the slightly warmed refrigerant travels back outside to the air conditioner, where it's cooled and recirculated. Integral systems with forced air. As we said earlier, forced air heating units deliver the heat from the unit to the rooms through a ductwork system. During the cooling season, the system can automatically reverse to provide cool, dehumidified air for air conditioning through the same duct system. Air conditioning. Air-cooled and water-cooled systems. The difference between air-cooled and water-cooled units is the method used to condense the refrigerant as it leaves the compressor. Air-cooled units use air as the condensing medium and have a fan that moves the air over the coils. Water-cooled units use water as the condensing medium and use a pump to circulate the water through the condenser and out to a cooling tower. Air-cooled units typically cost less to purchase and maintain because they do not require a cooling tower, pumps and condenser water chemical treatment. However, water-cooled units are generally much less expensive to operate because they can take advantage of lower condensing temperatures. Btu Ratings. A British thermal unit is the amount of heat energy needed to raise the temperature of 1 pound of water by 1 degree Fahrenheit. Btus measure the amount of heat an air conditioning unit can remove from the room. As the Btu rating increases, so does the size, weight and cost of the unit. Life expectancies. Most central air conditioning units can be expected to last about 15-20 years. However, this number may be affected by the climate and the geographical location of the unit. For example, a central air conditioning unit in Florida probably has a life expectancy of closer to 10 years. Heat pumps. For climates with moderate heating and cooling needs, heat pumps offer an energy-efficient alternative to furnaces and air conditioners. Like a refrigerator, heat pumps use electricity to move heat from a cool space into a warm space, making the cool space cooler and the warm space warmer. During the heating season, heat pumps move heat from the cool outdoors into the warm house. During the cooling season, heat pumps move heat from the cool house into the warm outdoors. Because they move heat rather than generate heat, heat pumps can provide up to 4 times the amount of energy they consume. The most common type of heat pump is the air source heat pump, which transfers heat between the building and the outside air. Higher efficiencies are achieved with geothermal heat pumps, which transfer heat between the building and the ground or a nearby water source. Advantages and disadvantages. Air-to-air. The advantage of an air source heat pump is its simple installation and competitive pricing. The disadvantage of an air source heat pump is that in climates with extended periods of freezing temperatures, such as New York, they have large limitations. The air temperature outside is usually the lowest when the need for heat inside is the greatest, compelling users to use electric or gas heaters as backup. Ground source. An advantage of a geothermal heat pump system is that it typically has lower maintenance costs than conventional systems as all equipment is installed inside the building or underground. The main disadvantage is that geothermal systems tend to have a somewhat higher first cost than conventional systems. Plumbing systems. Structural plumbing is actually made up of 2 systems, the water system that comes into the home for drinking, cooking and washing, and the drainage system for wastewater. Building codes specify how each system must be installed. Hot water heaters. Gas hot water heaters are very popular. These units have an insulated tank where water is heated and stored until it is needed. They offer fast recovery times and can offer more economy over electric water heaters. The standing pilot light gas water heater has a pilot light which remains lit 24 hours a day, 7 days a week and consumes gas to stay lit, while a gas-fired water heater with electronic ignition only lights a pilot light when it's necessary to fire the main burners. Electric hot water heaters are also storage tank units and are very popular because they are inexpensive and easy to install. Electric heat is 100% efficient, but the cost per kilowatts per hour of electricity is more than the cost of using a gas-fired water heater. Electric hot water heaters are also slow to recover as compared with gas-fired water heaters. However, maintenance of the electric water heater is easier as it requires very little maintenance. Tankless hot water heaters are basically on-demand water heaters. When the consumer opens the hot water faucet, a flow switch senses the flow of water and the water heater fires up and begins heating the water passing through its heat exchanger. Within seconds hot water comes out of the faucet. There is no tank to maintain or worry about leaking in the future. These systems are economical and last many more years than a regular water heater with a tank. They require little maintenance. Since they are on demand, the tankless water heater only uses fuel when hot water is needed. More on hot water heaters. Solar hot water heaters are generally composed of solar thermal collectors, a fluid system to move the heat from the collector to its point of usage. The system may use electricity for pumping the fluid, and have a reservoir or tank for heat storage and subsequent use. The systems may be used to heat water for a wide variety of uses, including home, business and industrial uses. Many people who use hot water boilers for their heat also use a domestic hot water coil in their boiler, which produces hot water for domestic use. The hot water boiler domestic coil is located inside the boiler heat exchanger and uses a constant supply of water which it heats as it passes through the coil. This water supply is separate from the water supply which is in the boiler loop. It is not the same water and has a different pressure than the water which is used for heating the home. One disadvantage of using the hot water boiler for domestic hot water production is that the boiler will also run in the summer. This adds heat to the location where the boiler is installed. So if the hot water boiler is installed in the home, the air conditioner will have to work much harder. Types of pipes. The types of pipe used in plumbing systems include the following. Cast iron, used for underground drainage systems because of its strength and sturdiness. It can be lightweight or heavyweight, depending on the application. Iron pipes are very heavy and are prone to rusting on the inside. Galvanized, used for hot and cold water supply lines. Galvanized steel pipe was commonly used years ago for the water supply lines, but more recently it has been replaced by other types of pipe. Steel is not used for underground plumbing. Copper, used for both water supply lines and drainage. Copper lasts longer than other metal pipes. It is easy to work with and resists corrosion. Copper is used for both hot and cold water supply lines. Copper pipe can be rigid or flexible, depending on the application. PVC, used mostly in areas where hard water is a problem. PVC is plastic pipe, so it is very lightweight and inexpensive. Unlike metal pipe, PVC crushes more easily, is less resistant to heat, and requires more support because it is so much more flexible than metal. Some municipalities including New York City have restrictions on the use of PVC pipe. Brass, rarely used in plumbing installations today because of its expense. PEX, ideally suited for potable water plumbing applications. It is flexible, making it easy to install and service. PEX is able to withstand the high and low temperatures found in plumbing and heating applications, and it is highly resistant to chemicals found in the plumbing environment. PEX is also very resistant to freezing and breaking. PEX systems have fewer joints and are easier to install, providing a lower cost installation over traditional plumbing materials. Plumbing. Pipe size. Building codes dictate the minimum pressure for plumbing fixtures. The codes also dictate the maximum pressure allowed, which is the highest pressure that will not cause damage to the system. Pipes that are too small or those that have a mineral deposit buildup prevent the pressure from moving the water to the fixtures. Pressure regulating valves can reduce and maintain the correct water pressure within the system, while a booster pump can increase the pressure if needed. Venting requirements. Water and wastes are carried from the kitchen, laundry and bathroom fixtures through a system of pipes that lead to the main structure drain. A venting system is made up of pipes that allow air to flow to and from the drainage system. The vent system allows gases and odors to circulate up through the system and escape into the outside air. Every plumbing fixture should be connected to a vent pipe that leads to a roof vent pipe. The local building code dictates the venting requirements. Electrical systems. The installation of an electrical system should take into consideration both present-day and future needs. The standard service is 120,240 volts of electricity. The electricity is brought into the building through a system of outside cables which can be either above ground or below ground. Responsibilities. It is the responsibility of the utility company to bring the electricity to the building's service drop or service lateral, the place where underground cables connect to the building. The owner of the property is responsible for taking care of all other parts of the service. This includes inside wiring, the service panel, fuses and in some cases the electric meter. Voltage and amperage. Voltage is a measure of how much pressure the electrons in a circuit are under. Amperage is a measure of the amount of electrons moving through the circuit. For example, when a light is on, there is a voltage across the filament of the bulb that is pushing amperage through the circuit. When the switch is off, there is voltage across the switch, but there is no current flowing because it is blocked by the switch. Most of the time you can identify whether an appliance, a tool or a fixture, such as a lamp, is 110 or 220 by looking at a tag that is attached to the appliance or fixture. Also, the plugs and receptacles for the two types of voltage are different. In most cases, 110-volt plugs have either 2 straight prongs or 3 straight prongs, while 220 plugs have 3 prongs, 1 straight and 2 that are L-shaped. Amperage. The electrical capacity needed for a particular structure is determined when it is built. Amperage is calculated in watts or kilowatts and the amount needed depends on the electric usage projected for the building. If the wire size or service is not strong enough for the building's needs, the circuits can overheat, resulting in blown fuses or tripped circuit breakers. A fuse is a protective device containing a wire that melts and breaks a circuit when the current exceeds a certain value. Melted or blown fuses can be replaced with new ones. A circuit breaker is an automatic switch that stops the flow of electric current in a suddenly overloaded or otherwise abnormally stressed electric circuit. Circuit breakers trip. Unlike fuses, they don't need to be replaced, just reset. Identifying amperage. The panel where the fuses or circuit breakers are located may have an amperage rating written on it. However, the only sure way to know the service size is by looking at the service entrance cables for a size indication. The number of fuses or circuit breakers is not an indicator of size, although each fuse or breaker can be identified as to the number of amps it can carry. This rating is specified in the National Electric Code. Diagram of electric box. Wiring materials. Wiring runs throughout the structure from the electric panel box through the walls to the outlets. Outlets can be plugs, switches and light fixtures. Aluminum versus copper. Aluminum wiring is used where the current is the heaviest, usually where the current comes into the building. It is also used for heavy appliances, such as dryers and air conditioners. Aluminum wiring has been known to cause overheating in outlets and switches that are not designed for use with aluminum wire, so older buildings should be inspected to be sure there are no potential wiring problems. Copper wiring does not overheat and it can carry both large and small loads. Most new buildings have copper wire throughout, except at the service entrance where aluminum is still used. BX cable. BX cable is technically known as armored cable or AC. It has a flexible aluminum or steel sheath over the conductors and is fairly resistant to damage. Romex cable. Romex is a brand name for a type of plastic insulated wire, sometimes called non-metallic sheath. The formal name is New Mexico. This cable is suitable for use in dry, protected areas that are not subject to mechanical damage or excessive heat. Most new homes are wired almost exclusively with New Mexico wire. Wiring materials. Conduit. A pipe made from plastic, steel or aluminum that is used for protection and routing of electrical wiring. Conduit can be used for both above-ground and underground applications. Greenfield conductors. This is a type of flexible metal conduit similar to armored cable, except that the conductors are installed by the electrician. With armored cable, the armor is wrapped around the conductors at the factory to form a complete cable assembly. FMC is often referred to as Greenfield after the person who submitted the product for listing in 1902. FMC is not suitable for wet locations and it should not be buried underground or in concrete. It is easy to use and work with in small, confined spaces. National Electric Code. The National Electric Code covers the installation of electrical conductors, equipment, and optical fiber cables for the following: public and private buildings, structures, mobile homes, recreational vehicles, and floating buildings, yards, lots, parking lots, carnivals, and industrial substations. Installations of conductors and equipment that connect to the supply of electricity. Installations used by the electric utility, such as office buildings, warehouses, garages, machine shops, and recreational buildings, that are not an integral part of a generating plant, substation, or control center. Mandated guarantees and warranties. Home improvement contracts. New York business law states that any home improvement contractor who enters into a contract for more than $5,000 must deposit any payments he or she receives into an escrow account until the project is completed. If the contract provides for the owner to make one or more progress payments before substantial completion of the work, the contractor must give the owner a schedule of such progress payments showing the amount of each payment and the state of completion of the work, including materials. The owner can cancel the contract within 3 business days of signing it, by providing written notice to the contractor. The 3-day right to cancel the contract can be waived for emergency repairs if the owner initials the contract and gives the contractor a written waiver statement. If a contractor secures a contract through fraudulent misrepresentation, the owner can sue the contractor, and if successful, the owner can receive $500 plus attorney's fees and other damages. If a contractor violates the deposit provision, he or she could be fined up to $250 or 5% of the contract price up to $2,500. Mandated guarantees and warranties. New home construction. According to New York business law, every contract for the sale of new housing implies a 1-year builder's warranty against construction defects, a 2-year warranty for plumbing, electrical, heating and air conditioning systems, a 6-year warranty for material defects, carbon monoxide detectors. The Fire Prevention and Building Code of New York requires that at least one carbon monoxide detector be installed in all 1- and 2-family homes, condominiums and cooperatives that were built on or after December 1, 2002. The detector can be hardwired into the electrical system or it can be battery operated. In New York City, the detector must be placed within 15 feet of the main entrance to the bedrooms. Owners must file a certificate of installation with the Department of Housing Preservation and Development within 10 days of installation. Smoke detectors. An operable single-station smoke detector must be installed in every 1- and 2-family home, condominium and cooperative in New York. The smoke detector must be installed in such a fashion to be clearly audible in every sleeping room, even with intervening doors closed. Each apartment in a multiple dwelling must have at least one clearly audible smoke detector. In NYC, smoke detectors must be installed in every apartment and near each sleeping room. Affidavit for smoke alarm and carbon monoxide detector in the sale of all 1 and 2 family homes, condominiums and cooperatives. The seller must give an affidavit to the buyer that states the dwelling has operable smoke and carbon monoxide detectors. The buyer has 10 days from the date of the deed to notify the seller if the alarms are not working, at which point the seller must pay to fix or replace them. Check your understanding. Print this screen, answer the questions and then advance to the next screen to see the answers. 1. What is the most common type of heating system in North America and how does it work? 2. What are the 2 types of heat pumps available? 3. Name 3 types of pipes used in plumbing systems. 4. What is the difference between voltage and amperage? Check your understanding. Answers 1. What is the most common type of heating system in North America and how does it work? A forced air heating system is the most common. It draws room air through ductwork and a filter into a furnace, where the air is heated. The warmed air is then blown back to rooms through ductwork. 2. What are the 2 types of heat pumps available? Air source and ground source. 3. Name 3 types of pipes used in plumbing systems. Cast iron, copper, PVC. 4. What is the difference between voltage and amperage? Voltage is a measure of how much pressure the electrons in a circuit are under. Amperage is a measure of the amount of electrons moving through the circuit. Summary review. This concludes Chapter 18. Below is a summary which you can review before taking your quiz. The New York State Department of Health provides guidelines for the construction of on-site wells. The New York State Department of Health also regulates the installation of individual wastewater treatment systems that receive domestic-type sewage flows of less than 1,000 gallons per day. New York's Comprehensive Energy Code establishes minimum regulations for energy-efficient buildings using prescriptive and performance-related provisions. Developers must consider all of these site issues prior to and during construction. Drainage, landscaping, shading, walkways. The typical parts of a structure are footings, foundation walls, wood framing, floor framing, roof framing, wall and roof finishing. Summary review. Summary. There are 3 types of frame construction. In platform frame construction, first floor joists are completely covered with subflooring to form a platform upon which exterior walls and interior partitions are erected. In balloon frame construction, exterior wall studs continue through the first and second stories. The third type of frame construction is called post and beam construction. In this framing method, wider beams are spaced up to 8 feet apart. Floors and roofs are covered with 2-inch planks, which serve as subflooring and roof sheathing. There are several categories of insulation: loose fill, batts and blankets, rigid board, spray foam and reflective. Many heating and cooling systems are referred to as HVAC systems. Residential heating systems typically fall into one of these categories: hot water, steam, forced air or electric. Most heating systems use a furnace to heat the air and a ductwork system to disperse the heat. There are 3 types of air furnaces: electric, oil-fired and gas-fired. The Department of Environmental Conservation does not regulate underground storage tanks or above-ground storage tanks that are less than 1,100 gallons. Forced air heating units deliver the heat from the unit to the rooms through a ductwork system. During the cooling season, the system can automatically reverse to provide cool, dehumidified air for air conditioning through the same duct system. Summary review. Summary. The most common type of heat pump is the air source heat pump, which transfers heat between the building and the outside air. Higher efficiencies are achieved with geothermal heat pumps, which transfer heat between the building and the ground or a nearby water source. Structural plumbing is actually made up of two systems: the water system that comes into the home for drinking, cooking and washing, and the drainage system for wastewater. Building codes specify how each system must be installed. The installation of an electrical system should take into consideration both present-day and future needs. The standard service is 120,240 volts of electricity. The electricity is brought into the building through a system of outside cables which can be either above ground or below ground. The National Electric Code covers the installation of electrical conductors, equipment, and optical fiber cables for most public and private buildings, structures, mobile homes, and recreational vehicles. New York business law states that any home improvement contractor who enters into a contract for more than $5,000 must deposit any payments he or she receives into an escrow account until the project is completed. Summary review. Summary. According to New York business law, every contract for the sale of new housing implies a 1-year builder's warranty against construction defects, a 2-year warranty for plumbing, electrical, heating and air conditioning systems, a 6-year warranty for material defects. The Fire Prevention and Building Code of New York requires that at least one carbon monoxide detector be installed in all 1 and 2 family homes, condominiums and cooperatives that were built on or after December 1, 2002. An operable single-station smoke detector must be installed in every 1 and 2 family home, condominium and cooperative in New York. Click here if you would like to open this summary as a PDF, which you can then print or save to your device. Chapter 18 Summary. Chapter Conclusion. In this chapter, we have discussed land use issues that a construction project must take into consideration, site requirements specific to New York, structural components, major mechanical systems, including heating, air conditioning, plumbing and electrical, guarantees and warranties that are mandated for home improvement and new construction. In the next chapter we'll discuss environmental issues. Now it's time for your chapter quiz. Good luck! 1 of 19 in construction. Exterior wall studs continue through the first and second stories. First floor joists and exterior wall studs both bear on the anchored sill. Balloon frame. 2 of 19. What on-site system is designed to treat and dispose of domestic sewage? A septic system. 3 of 19. A building envelope is the outer shell that protects the indoor environment. 4 of 19. Contractors and developers must apply for and receive before they can start construction. Building permits. 5 of 19. A is a protective device containing a wire that melts and breaks a circuit when the current exceeds a certain value. Fuse. 6 of 19. Steel cylinders that are filled with concrete and used to support the main floor beam are called lally columns. 7 of 19. What type of furnace has a heat exchanger to burn the fuel, which is either natural gas, propane, or butane? A gas-fired furnace. 8 of 19. Which of these types of wire would probably not be found in a residence? Steel wire. 9 of 19. The detailed set of plans that will be used as a guide to construct the building are the blueprints. 10 of 19. What does the New York Uniform Fire Prevention and Building Code require regarding vapor barriers that the National Building Code does not require? The barrier must be treated for termites. 11 of 19. What forms the bed for a structure's foundation? Ground. 12 of 19. What are 2 X.A.R used to frame the roofing system called? Rafters. 13 of 19. A septic tank contains that prevent scum and sludge from passing out of the tank. Baffles. 14 of 19. When a 1 or 2 family property is sold in New York, what is required? A smoke alarm and carbon monoxide detector. 15 of 19. The wooden support that serves as the base for the wall framing is called what? Sill Plate. 16 of 19. Which of the following documents is not filed with the planning board prior to construction beginning? Building permit. 17 of 19. If the area between the foundation walls has been partially excavated, what is the result? A crawl space has been created. 18 of 19 The double top plate used in load-bearing walls is called a flitch beam. 19 of 19 Where would a contractor find a list of materials needed for building construction? The specifications.